Last year, billions of dollars were invested in data centers, the powerful computer processing facilities, which essentially form the unseen backbone of the internet. And the advent of artificial intelligence is only spurring on demand for these facilities, with operators looking to build specialized data centers to facilitate the training and deployment of AI applications. The problem is power. Data centers require huge amounts of resources in terms of land, water, and electricity. Some campuses are so large, they can require more than 1 gigawatt of electricity. That's more power than some small cities use. So in the face of these challenges, data center operators are looking to evolve their own power ecosystem to speed up development and meet that surge in demand.
So an AI data center generally is much larger in terms of scale. So whereas normal data centers might have been 10, 20 megawatts, the new generation of AI data centers are 100, 200 megawatts, and they're growing every day. And they're growing because of the density, the number of racks you can fit into the same space. So here in our first building, we're delivering racks of 60 kilowatts today. Tomorrow for our customers, it's going to be 120, 130 kilowatts per rack, and that keeps growing every year.
About a 2-hour drive from Lisbon, nestled next to one of Europe's longest beaches, is Start Campus, a new AI data center that when completed will host 1.2 gigawatts of capacity. Its operators claim it's the most sustainable facility in Europe, powered by 100% renewable energy. Water usage and cooling demands are often the most energy-intensive aspects of AI data centers, as high-powered chips that are essential for the training of large language models require high-density computing power and therefore produce more heat. Start Campus features a mixture of liquid and air cooling and makes use of the leftover infrastructure of a nearby decommissioned power plant to recycle seawater through its system, thereby achieving a water usage effectiveness of 0. Grid access has already been obtained to power the remaining 5 buildings.
So we recognised from the very start when we were going to be building these large-scale data centres of multiple hundred megawatts that we had to do so sustainably so that we could be in the market for the long term. It starts with site selection. So when we looked at a broad number of sites around Europe, we were looking for ones that would have access to renewable power. We were looking for sites where we could deploy an efficient cooling solution, and obviously sites that were well connected as well. But this site in Sines ticked those first 2 boxes in terms of renewable power. So Portugal, already on the grid, has renewable power in the form of solar, wind and hydro. Last year the grid consumption was over 70% renewable resources. Also with this particular site, when I say we were able to use an efficient cooling method, we're right next to the sea. So we're able to utilise a seawater cooling facility that was used by an old coal power plant, and we use that to drive down the efficiency of our data centre. So the seawater is how we discharge the heat from the data centre, and then within the data centre we're deploying both air cooling and liquid cooling, which is necessary for cloud applications, AI applications, regardless of the density. So liquid cooling will be a big part of future deployments. We've already got a smaller deployment here in our first building that's using liquid cooling, but it's an absolutely necessary part of those data centers that are going upwards of 100 kilowatts per rack.
So here at Start Campus, we're having to be escorted by security because this is a massively secure location, so we can't actually just walk through on our own. This is the power room, which is used for keeping the data center operational in the case of any kind of grid failures. And that sound you can hear, that is the cooling system keeping this electrical room cool. See, as artificial intelligence skyrockets demand for electricity, the existing power infrastructure is struggling to keep up. Companies have spoken of wait times of up to 8 years to secure permits to connect their business to the power grid in Europe, which is often in dire need of modernization. Our stakeholders in the industry have been battling these challenges for some time now, and they're looking to new technologies to speed up efficiency and improve sustainability. Companies are looking to technologies like microgrids, strategic charging and battery storage as a way to move forward.
Data center queues to interconnect into the grid across each of the major geographies is increasing, right? And so we are in a planet today where across some of the major geographies, a wait time to interconnection can be as high as 7 years, which is a historical high. But quite frankly, the grids haven't seen this volume of incoming requests in quite some time. At the same time, the grid build out in Europe is faced with a competing challenge of growing to connect ever-increasing renewable resources, and also meeting the demand of these data centers that are emerging, which are one of the largest value pools of growth within the energy sector in Europe today.
For other hyperscalers, securing grid access isn't always so easy. Energy management firm Schneider Electric warned in a January report that Europe faces a looming power crunch. Still, Schneider Electric is confident that the industry can overcome these issues by investing more in on-site generation and energy storage. The question is, how speedily can these developments be made to overcome the challenges of lack of grid capacity and rising operational and energy costs?
So the current technologies are a mix of what we already have and what we are working on, right? So what we already have is, like as an example in this campus, the entire powertrain, so sustainable switchgear systems, the most efficient and smallest footprint, hence sustainable UPS systems, the low voltage, medium voltage equipments, the entire software play. So all of those technologies exist today. From a perspective of storage becomes an interesting solution when you're thinking about overall renewables, because you're taking the energy, you need to be able to store it somewhere. So the big energy systems, as they call them, the BESS systems, those are an integral part of what is being built in many of the sustainable data centers today. We do not see a slowdown. I mean, and I'll give you a few data points. When you think about the largest hyperscalers on what they're totally overall investing in the AI build-outs, that's not slowing down. Now there are some change of designs here and there, and that's why some of them, you may see a little bit of a blip. Then when you think about the amount of money which is going from the capital markets into this industry, it is also not slowing down. And on top of that, when you look at how compute technology is evolving, which makes it even better from an AI perspective, don't see a slowdown at all. Can we have clean electricity through decarbonization of the grids? Right? Now there is a plan. Globally there is a plan, but that needs to be executed. Secondly, can we distribute that energy so that the transmission happens at the right spot? So again, a lot of effort which is needed in this space. And then one last thing I'd say is also for different governments in different parts of the world, can we all agree that this is all for a cause which is better for the planet versus not just trying to deplete the planet? So if you keep these three aspects in mind, there is enough available out there with which we can create green energy for the data centers.
The marriage between a data center and a nuclear facility on paper is very obvious, right? You demand constant carbon-free electricity, and you have a source that could potentially supply that. Now, of course, that doesn't come without any risks or challenges, because there's the element of how do you then deal with the waste of a nuclear facility? How do you deal with the securities, etc.? But from a technical feasibility perspective, it's a quite interesting question.
Star Campus is just one example, offering a glimpse at the sheer scale of some of these projects that are currently in development across Europe and around the world. With the AI revolution well underway, the infrastructure needed to power this burgeoning market will also need to keep pace. This is April Roach reporting for CNBC International.